Everyone, this is Group 1 presenting a project titled Comprehensive Analysis of Amazon Book Reviews using MapReduce. And below are the group members: Andrew, Rafael speaking, Joanne, Adija, Helen, and Charles. So there has been rapid growth of e-commerce platforms, and this has led to an explosion of user-generated content, particularly in the form of product reviews, ratings, and as well as feedbacks. What we note is these reviews not only influence consumer purchasing decisions, but also this has provided a rich source of data for understanding what we refer to as user preferences, sentiment trends, and as well as predicting or having an insight on overall product performance. However, these sheer volumes of unstructured or the unstructured nature of this data pose significant challenges for traditional data processing techniques. And majorly to address these challenges, one framework that is notable that solves this is MapReduce, which is what we are going to be pitching to you. And we realize that this MapReduce will provide a scalable solution for breaking down complex tasks into parallel processes for efficient big data analysis, as the subsequent group members will share. So in this project, we use some major tools and libraries. Some of the libraries used are MRJob, Multiplotlib, majorly for plotting these visuals, as well as the tools. The tool that we majorly used in this project is the PyCharm IDE. So our data set is originating from the Amazon Reviews dataset, which we collected from Kaggle, and it has quite a number of features comprising of things like ID, title, user ID, reviews, or the different scores, of which this majorly are the star rating given by the reviewer. And moving on, we have things like the helpfulness, as well as review text and review time. So this is what comprises of our data set as listed below. Moving on, let me hand over to my next colleague, Joanne.
Hello, everyone. I'm going to take us through what we did for counting reviews per book. The task, the workflow for this task used MRJob to count reviews per product while retaining the product titles for visualization. The mapper process processes each input line while skipping headers, split lines by commas to extract the product ID and the product title, and emits a composite key consisting of the product ID and product title with a count of 1. The reducer aggregates the counts by this composite key, summing values to compute the total reviews per product. And this is a chart that was plotted from our results. In this bar chart, it displays the number of reviews we received for each of the different books in the data set. Whispers of the Wicked is at the top of the list, and it received the highest number of reviews, followed by the Eyewitness Travel Guide and Alaska Sourdough, with about 27 reviews. The majority of the products received 5 or lower reviews, including the Battleship Bismarck, Muslim Women's Choices, and the New Conspiracy Reader, with 2 reviews each. This graph effectively illustrates the distribution of customer engagement across the product catalog, highlighting which items have generated the most feedback. And then we went on to task 2, which was computing the average rating per book. Here, our mapper function extracted book titles and their corresponding ratings from each review record, emitting each as a key value pair along with the count. The reducer then aggregated all the ratings for each title, summing the scores and dividing by the total count to compute the average rating. This distributed approach ensures efficient processing of large-scale data, enabling the extraction of meaningful insights such as the highly the most highly rated books based on user-generated reviews. And an analysis is that this bar chart analyzes the average user rates for every book in the dataset, considering the top 50 books, revealing distinct trends in reader preferences. The top rated books, including A Husband for Kitani, Cien Años de Boxeo, and Dealing with Disappointment, achieved the 5.0 score, which is a perfect score, likely due to their niche appeal. A high rating cluster, which is 4.7 to 4.9, includes books with titles like Treat Yourself to Life and Hunting the Hard Way, suggesting strong satisfaction amongst targeted audiences. Mid-range ratings between 4.0 and 4.5, such as Dr. Seuss and American Idol, with 4.6 reflects polarized opinions, while outliers like Anna Karenina with 1.0 and The New Conspiracy Reader with 2.5 indicate significant dissatisfaction, potentially due to the poor extraction or unmet expectations. Notably, Whispers of the Wicked Saints, despite having the highest review count of 3, earns only a 3.8 average rating, underscoring the disconnect between the popularity and the perceived quality. And then from there, we moved on to the next task, which was identifying the top 10 most reviewed books. And here, to identify the top 10 most reviewed products, we designed a two-step MapReduce job. In the first MapReduce step, the mapper reads each line, extracts the product ID and title, and emits a key value pair of the product ID and a tuple containing the title and account of one. The corresponding reducer receives all tuples for a given product ID, aggregates the review count by summing the values, and emits a new key value pair with a non-key and a tuple of the total count and title. This use of the non-key ensures that all the data is sent to a single reducer in the next step for global sorting. In the next reducer, we sort all products by their total review counts in descending order and extract the top 10 entries. The final output consists of the titles of the most reviewed products along with their corresponding review counts. This output is then read into a separate plotting script that visualizes the results using a horizontal bar chart, providing a clear and intuitive value of the most popular products based on review volume. And I'm going to hand over to our next classmate. Thank you for listening.
Thank you, Joan. So I'll take you through the task that was to calculate the average helpfulness score. Sorry, my name is Hadija Atman. So to calculate the average helpfulness score for the review, we calculated this using total helpfulness score divided by the total votes. Sorry, you calculated this through total helpfulness votes divided by the total votes, that is both the helpful and unhelpful. And as you can see here, our total helpfulness score for all the reviews was 0.6782. But then we went ahead and plotted and visualized the helpfulness score for each star rating, and you can see that there's a positive correlation between the star rating and helpfulness score, in that reviews with the 1-star rating have the lowest average helpfulness score, suggesting that negative reviews usually have they're marked as less helpful by others, and then more positive reviews have higher ratings, as you can see from the graph. So the next task was this is now under the additional analysis, where we want to see the sentiment analysis for the text, for the review text within the dataset, and we can see that the positive reviews had the highest value, that is slightly below 300, whereas the negative and the neutral had the lowest numbers. And under this category, the positive reviews had the highest number, which means generally most of the customers had something good or had something nice to say about the books. And of course, the negative ones, we had very few customers who had the negative reviews, which means they're like dissatisfied with the product. And then we had also very few customers who did not really mind about giving feedback, like they were not satisfied or dissatisfied. Then we also plotted a graph to show us a time-based analysis of the rating. That is over the months, how are the ratings like for the books. And as you can see here, the month of March and September have the highest average ratings, indicating that the reviews in this month were more positive. And we can relate this to the previous graph where we had more positive reviews. So March and September had more reviews, and that is more positive compared to all the other months. And then we can see that June had the lowest rating, that is probably 3.8 or 3.9, slightly lower than the others, suggesting that in this month, we had less positive reviews overall. And from the overall analysis, we can see that most of the ratings were between 3.8 to 4.6. And there's a consistent positive sentiment, as you can see in the graph throughout the year from January to December. And next, we wanted to check out the correlation between the helpfulness score and the star rating. And I already explained this a little earlier. We see that the average helpfulness score has a more positive correlation with the star rating, in that ratings that have a lower value are less helpful compared to the ratings that have a higher value. Like you can see here, the ratings of 1 has a very low helpfulness score of about 2.5 compared to the star rating of 5 that has nearly 7.9 rating. I'll hand over to Helen.
Thank you so much, Hadija. My name is Helen Nakaungu, and I'll start with this task 8, which is the frequent word analysis in review text. This bar chart shows the top 10 most frequently used words in positive reviews from the data set. The words wicked, saint, and whispers appear with the highest frequency, each occurring more than 30 times. Other notable words including school, law, Dratica, screenwriter, series, beginners, and designs, their frequency is notably lower. This distribution suggests that readers frequently mention specific themes such as characters, like wicked, saint, also narrative elements like whispers, and context related to education and writing like school, law, screenwriters. The prominence of these terms indicates that positive reviews are often focused on storytelling, character development, and instructional value. Such insights can help authors, publishers, and marketers understand the aspects of books that resonate most strongly with satisfied readers. Moving on to next slide. So in conclusion, this project demonstrates the power of the MapReduce programming model in analyzing large-scale Amazon book review data by leveraging distributed computing with the Mr. Job library in Python. We efficiently carried out tasks such as counting reviews, computing average ratings, identifying top reviewed books, and evaluating review helpfulness. Additional analysis, including sentiment classification, time-based trends, and word frequency, provided deeper insights into customer behavior and preferences. Overall, this study highlights how scalable data mining techniques can transform raw and structured data into meaningful and actionable knowledge in the context of e-commerce. Thank you.